MiniUSB. The Mini-USB connector was the first major step toward compact, standardized charging and data transmission for portable electronics. Introduced in the early 2000s as part of the USB 2.0 specification, it was designed to replace the much larger Type A and Type B ports on devices where space was a premium. While it has been largely superseded first by micro-USB and now by USB-C, it remains an important legacy standard found on digital cameras, older GPS units, and specialty hardware like graphing calculators and some automotive dash cams. The physical evolution and durability. The most common version of this connector is the Mini-B. It is significantly smaller than a standard USB port, but thicker than the more modern micro-USB. It features a distinct 5-pin, stepped shape that prevents incorrect insertion. Unlike its successor, micro-USB, the Mini-B connector relies primarily on the friction of its metal outer shell to stay connected to the device. Because it lacks the spring-loaded locking hooks found on micro-USB, it is often perceived as more robust by technicians. The connector is rated for approximately 5,000 insertion cycles. While this is half the rating of micro-USB, the thicker internal, tongue, and sturdier metal housing make it less prone to bending if a user accidentally applies sideways pressure to the cable. However, the downside of this friction-fit design is that the port on the device itself can become loose over time, requiring the metal shell to be slightly squeezed to regain a tight connection. Technical layout and data transmission. Like its siblings, the Mini-USB connector utilizes a 5-pin architecture to support USB 2.0 high-speed data. The internal pinout is identical to the standard mobile wiring. Pin 1, power positive 5 volts. Pin 2, data minus. Pin 3, data plus. Pin 4, ID, identification for on-the-go functions. Pin 5, ground. Under the USB 2.0 standard, it supports data transfer rates up to 480 megabits per second. In the field, you will often find that Mini-USB cables are shielded more heavily than basic micro-USB cables. This is because Mini-USB was frequently used for high-bandwidth data transfers from digital cameras and external hard drives, where signal integrity over long transfer sessions was critical. The specialized Mini-A and proprietary variations. One point of confusion for technicians is the existence of the Mini-A connector. While the Mini-B is the peripheral end we see on devices, the Mini-A was designed to be the host end. However, it was extremely rare and eventually phased out in favor of the more universal Type A port. A bigger challenge in the field is the proliferation of proprietary Mini-USB shapes. In the mid-2000s, manufacturers like Nikon, Sony, and Olympus created modified versions of the Mini-USB port to carry additional signals, such as analog audio or video out. These proprietary ports often look very similar to a standard Mini-B, but have extra pins or a slightly different rectangular shape. A technician must be careful not to force a standard Mini-USB cable into these proprietary jacks, as it can permanently damage the internal pins. Troubleshooting and field maintenance. The most common failure point for Mini-USB is mechanical fatigue of the solder joints. Because the connector is relatively tall compared to micro-USB, it acts like a lever when a cable is plugged in. If a user frequently wiggles the cable, the stress is transferred directly to the points where the jack is soldered to the motherboard. Technicians troubleshooting a device that only charges when the cable is held at an angle are usually dealing with cracked solder joints. In many cases, this can be repaired by reflowing the solder on the pins. Another common issue is internal pin corrosion. Because these connectors were often used on outdoor gear like GPS units and cameras, they were frequently exposed to moisture. If a device fails to sync with a computer, the first step is to inspect the 5 copper pins inside the jack for the green or white crust of oxidation, and clean them with a precision electronic cleaner.